Okay, guys, let's try this again. I'm sorry, I think that I was giving you guys an example. It said x plus y is equal to 7. Okay, let's try this again quickly. We had built up a good group of stuff here. Can someone give me some solutions? Simon? 15. And
8.
no, that would give me 23. Armand, can you and negative 8. That would be good. All right. Simon's mad because he had a good pair and he messed that up. All right, that's all right. No worries. Alex? 1 and 6. Good. Okay. Alex isn't going to be fancy. He's just going to get the job done. Liam? 7 and 0. Nifty little answer right there. Okay. Zachary, can you give me one that doesn't work? 3 and 4.1. Exactly. That doesn't work. Okay, if I plug that in, that doesn't give me 7. Okay? So, what we're saying is there are combinations, there are ordered pairs that are not solutions, and there are ordered pairs that are solutions. But Teddy, how many ordered pairs are there that are solutions? Infinite number, right? I mean, I can do lots of different combinations. How about 100 and negative 93? Sure. How about 101 and negative 94? Yeah, we can do that one too. I don't ever have to stop that, do I, Kai? These things go on forever and ever. So when I give its answer, I can't just say x equals this or y equals this to represent all of the solutions. I'm actually going to graph the solutions. Okay? And a graph is a picture of all of the solutions to an equation. And there are infinite solutions. Okay? But first, that's not what this one's asking us to do. We'll do that in the next example. Example number 1 is just saying, tell whether the ordered pair is a solution of 2x minus y equals 5. How can I figure that out? How did I figure it out with this one, with x plus y? What did I do to figure out if it was a solution? Albert? I plugged it in and just saw if it was true, right? So that's what I need to do for these over here. 1 and negative 3 and 4 and 7. I just need to plug them in and see if they give me a true statement. Okay? So here, let me get rid of this, get this out of our way. All right? I'm going to take the equation, I'm going to rewrite it with parentheses, like this, and then I'm going to plug it in. Mr. Cortez, do I have to write it with parentheses? I'm going to say, yeah, you do. Write the parentheses. Because what happens is, a lot of people think that this negative stands for that negative, and it doesn't. It's saying the opposite of whatever y is. And in this case, y is negative 3, so it's going to make it positive 3. Watch what happens. I'm going to get rid of this so we don't confuse ourselves. But let's plug in the values now. What goes here, Tut? 1. What goes here, Ethan? Negative 3. What do I get when I multiply those two things, Liam? 2. And how does this simplify, Fritz? Plus 3, because net minus a negative is positive. All right, and then 2 plus 3 gives me 5 equals 5. Is this a true statement, Armand? It is a true statement. So that means that this is a solution to that equation. Good. Let's do the same thing for the other one. Kai, I'm going to rewrite the equation, but I'm going to write it with parentheses because I want to make sure that I include the signs correctly. Okay? Justin, tell me what goes into this parentheses. 4. And Tut, what goes into these parentheses? 7. Good. What do I get, Zachary, when I multiply here? 8. And what else should I include, Nico? What do I do now? Minus 7. Good. All right. What do I get when I put those two things together, Cole? 1 equals 5. Does 1 equal 5, Cole? Good job. It does not equal 5. And this is not a solution. That's all it asks us. Find out if this is a solution. We plug it in and see if it's true. If it's not true, it's not a solution. Great job, guys. See you at the next example.